Hi, I'm Scott. Welcome to Scott's Synth Stuff. On this channel, among many other things, I restore old synthesizers. I've done an SH-101 and JD-800. If you've missed either of those, I'll put links to them in the description below. But today is all about the Polysix. This is episode 2. If you missed episode 1, which is the introduction to this, I'll link that as well in the description below. In the meantime, let's get going on the Polysix. The first thing we have to do is open this up, and we'll then take some photographs because the last thing we want to do is forget how it goes back together. In order to do that, we're going to need JIS screwdrivers. JIS screwdrivers may look like Phillips screwdrivers, but they're not. JIS stands for Japanese Industrial Standards, and anything that came from Japan, including synthesizers, cars, uses JIS screws, not Phillips head screws. The difference is if you use a Phillips head driver in these screws, they will cam out and strip out the screw. You can tell it's a JIS screw because it has a little dot on the screw head. That tells you it's a JIS, so when you put the screwdriver in it, it fits in so well that it can never actually cam out and destroy your screws. These are Vessel JIS screwdrivers. I will put a link to these in the description below. They are the best screwdrivers period I've ever used, and they work just as well in Phillips screws as they do as JIS. So if you're looking for a set of screwdrivers, or you're going to be working on Japanese cars or synthesizers or anything else, get yourself a set of Vessel JIS drivers and use that link in the description below because it's an affiliate link. We make a couple bucks, okay, a couple cents, but still great screwdrivers, best I've ever owned. We're going to use some Ziploc bags because what we want to do is every time we take fasteners apart, we're going to put them in a Ziploc bag and then use a Sharpie to write on the bag what it is. Makes it a lot easier when you're trying to put it back together, when you're trying to remember what fasteners went where. Also, we will be taking pictures of everything inside that shows exactly how everything is connected up, because you might find a problem inside that there's a broken part and it's going to take 2 months to find one. And if you wait 2 months, I guarantee you're not going to remember how this thing came apart and you won't be able to put it back together correctly. So that's when taking pictures of the interior is just invaluable. I just do it as a matter of course. Even if I know it's going to be a short, simple repair, I just take pictures because you never know. It's cheap insurance. So let's get started. All right, the first bag will be for external hardware. And you can see the JIS screw has that little dot in there that indicates that, yes, this is in fact a JIS screw. So we have these 4 screws, 2 on each side. Now these 4 screws hold the case to the cheeks. I should mention I do have the service manual for this synthesizer. Most of these old synthesizers you can get the service manual for. You just find them online. People have scanned them. So once you've removed the top 4 screws, then there are 4 screws along the back somewhere. That's interesting. So I've removed the 4 screws from the top and the 4 screws from the bottom that hold the lid in top, that hold the lid in place. And as I lifted it up, this little screw dropped out. So I'm not quite sure where that came from, but we'll find it at home. And I'm pretty sure it is from this because, as you can tell, it has a little dot on there that says it's a JIS screw. So no doubt that is a Korg Polysix screw. So now that we've taken those screws out, we can open the lid and get a look inside. As you can see, I removed the battery out of here previously because I didn't want it leaking any further and causing any more damage before I had a chance to work on this. So that has been removed, but you can see all the corroded traces and damage done to the integrated circuits from the acid leaking out of that battery. All right, so now we're going to take some pictures of all the internal boards with all their connectors and wiring and so on. Quick tutorial on the layout of the Polysix. Here we have the input for the power. We have a power filter and fuse over here going into this transformer here. The transformer has 18 volts that comes out of here into the power supply board, 2 more fuses, some smoothing capacitors. It's a linear regulator. We then have the power supply running the various rails out to the different boards. This one here in the center is the CPU board. That's the one that causes us all the problems. Over here we have the actual synthesizer board where all the 1, 2, 3, 4, 5, 6. You have the individual voices and filters, and you can see we have SSM 2056 and 2044 voice and filter chips, along with all the trim pots for tuning this. Interestingly enough, there's a the connector for the Keybed is not connected to the voice board for some reason on here. And then over here we have the effects section, whereas there are chorus, ensemble, and so on. And obviously these are just the control boards. All of the controls come into the CPU board, which scans all the controls, and then it has D to A's that control all the voice characteristics and the actual synth. So our voice assigner is here on the board. So this Keybed is actually disconnected. That's fine because we're about to remove that anyway. And I see it's tied to our mod board there as well. Okay, so I'm going to actually close this up and remove the screws that hold the Keybed in place, and we're going to pull the Keybed out of here. So that's not too tough to do. There's several large screws, some of which are missing on this synth, so we're going to have to source some replacement Keybed screws. All right, the Keybed should have 6 screws holding it in. This one has only 3. We're going to have to find some replacements for that, but we will mark those down anyway. Keybed. Hopefully I can read my own writing down the line. And it's already disconnected, so we should be able just to lift this right out of here, which we can. There we go. So there's the Keybed. So these plastic spacers actually fit onto the bottom here, and they are used to prop up the circuit board that has the contact strip for the Keybed. These plastic pieces are just falling out left, right, and center. I'm going to lose them, so I'm just going to take them off now, and we'll put them back on later. Because anytime you have loose pieces falling off, they are just going to disappear, and then you'll never see them again. As I mentioned in the previous video, I did order replacement contact strip for these. I have no idea if this Keybed is working or not. On the off chance that it's bad, I've ordered a replacement. So we'll take that apart, we'll clean it, and put a new contact strip in there. As for the bushings and the felts, it looks in pretty decent shape. I don't think I'm going to have to do anything with the felt or the rubber bushings on this at all. It looks in really good shape. I don't think I'm going to have to disassemble this Keybed apart from just the rubber contact strips. So that's good news. We'll put this aside for now. When Korg built this thing, they didn't want it getting shaken apart on the road. So when they put all these connectors in, they put a little bit of glue on each one to hold it so that it wouldn't come apart. So in order to get these connectors out successfully, you do have to cut that glue off. Some of them, these have obviously been apart before, but some of them have not. And you can see that the glue's been off this one. This board's been out before, I can tell. This one has not. So somebody has done a bit of work on this synth before. So what we're going to do is disconnect all of these connectors off this board, because these boards are going to come out of here because we're going to be moving them into the new synth cabinet. And you don't have to disconnect all the wires. We can just disconnect one end of each. That's helpful because it obviously bends there and stays there and shows us where it actually intends to go. That's interesting. This is supposed to have a ground connection from here, this main CPU board, up to this panel, and that ground connection is broken. So I'm going to have to figure out where that went. I don't remember. It's somewhere up on one of these boards. However, we're going to be redoing all the grounds on this synth anyway, so that's not that big a deal. I was actually going to remove that anyway, so no problem. Okay, all the connectors on the main boards are undone. We'll take out the pitch and mod wheel section. And these are actually stapled and twist tied to the side here. So we'll just remove these twist ties, and I don't think we'll be recreating that on the new case. Wow, these are literally just thread ties that Korg has used to hold these on here. And then we can remove the pitch and mod wheels. So the pitch and mod wheels are just a set of 10K pots with wheels attached, as you can see here. So we'll spray those pots out and clean them out. But what I do notice, it's been a while since I used a Polysix. Like I've said, it's like 30 years. The mod wheel, obviously you can move it wherever you want. The pitch wheel has a detent in the middle, but it is not springing back to that detent. I don't know if there's a spring missing on here, or if it's just that's how it was and I just don't remember it. So I'll have to look that up. I looked it up. That's the way it was. I just didn't remember it. The Korg monopoly and the Polysix, the pitch wheel just had a detent but no spring. That's the way Korg did it before they moved to joysticks. Back to the video. The next step is to remove all the screws that are holding these boards in place. And there are also standoffs that are used to hold these boards away from the shielding there, that ground shield, that foil shield on the base. You can see the nylon standoffs there that are into the boards like that. Okay, so there's our first board right there. Yeah, see the standoff for this one actually popped out, so we'll just hang on to that. And there's some dust bunnies around in here. These boards are fairly clean for what they are, for the age they are. There is some dust, so we'll hit these with some isopropyl alcohol and clean these. But the other two boards have these board holders that just screw down in place. And then we can remove all the other screws holding the boards in place. The good old days when all these boards had all their test points labeled. I mean, you could see it tells you what each chip does, and I mean the labeling on these is just, they're meant to be serviced. Just wonderful. They don't make stuff like this anymore, unfortunately. All right, so here is the problem CPU board. This is the one that causes all the issues. Now we're gonna have to pull these standoffs off of it because I'm gonna need those. However, this board, even though it is non-functional, is going to have a new life. It is not getting thrown away. This CPU board is actually going to get sent down to Centaur in Texas. The good people at Centaur do board level repair, and they're going to have a crack at this. And if they can, you know, it's going to take them some time because they're going to have to go in and repair all the acid damaged etches and so on. But if they can fix this and get it working again, they will turn around and put it into another Polysix that might have a board that's irreparable, and it'll bring new life to another Polysix. So this may end up being the donor heart of yet another Polysix that today is dead. So there we go. That's the donor going to Centaur. We'll put that aside. And this is the true heart of the Polysix. Here is the actual synthesizer board. This is the voices, the voice assigner, the actual voices, the filters. This is it. This is the Polysix. I'm going to very gently put this one aside. All right, so this is the power supply here. There's a few things I want to do. I want to actually run some tests on this just to see what voltage I'm seeing coming out of this transformer. The circuit the diagram that I have says this is 18 volts AC across the 2 green, and then there's a ground in the middle. That's not what it looks like to me here. It looks like this is actually a center tap with a positive and minus 18. So I'm going to power this up and just measure the voltage here to make sure that it's showing what I expect it to see. Then we will power up, well, I'm going to have to take these connectors off this power supply board, because if this power supply is bad, I don't want it cooking all the LEDs and logic and components, discrete components on these boards here. But I do want to measure the rail voltages that this is putting out just to check to see if it is actually putting out the correct rail voltages, just out of curiosity. The one thing you do need to know about the Polysix is that over here on the power supply section, there are lethal voltages. These connectors right here are connected to the wall socket. So if you don't know what you're doing, please don't go in here and plug it in and just start touching things and messing around, because you can kill yourself. So what I'm going to do here is I'm going to get the power cord uncoiled here so that I can plug it in. We'll make sure it's actually turned on. And that way we can measure the output of this power supply. All right, so this is now energized. I'll get my meter over here. So coming in from the wall, we should have 120, which we do, and nothing across the fuse, which is correct, so that fuse is good. And then coming out of the filter, we have 120 there, and what is this here? 120, so I'm not quite sure what the we have the line and load. Not knowing what the colors are for this transformer, I'm not going to try and guess what's going in, because I don't, according to this, there's a line, a load, and a ground. Oh, that makes sense. If it's ground coming out, then, okay, so the center connector on this filter is ground, which is tied back at the panel to neutral, which is why I'm reading 120 volts. So these outer two here, the orange and the white, are the primary inputs, and then the black is just ground, and that's obviously to use as a filter for the internal capacitor in that filtering device. Okay, so our outputs here are green and black. Measure it there. I have 1.5 volts AC. Interesting. So across that, 1.5. No, there we go. 22 volts. And here we have 22 volts. And across the two is 45. So it looks like it's a center tap, 18 with, across the center tap. So the transformer that I bought, this nice toroid transformer I got, is fine. It's a dual 18 volts, so it's 18 plus 18 and 18 with a center tap, so it's exactly the same as this transformer. I was doubting myself, but I did order that based on the specs, so that should work just fine. So we have 18 and 18 volts here coming into the power supply. So now that should be rectifying that into DC. So now we'll switch to DC and see what measurements we're cutting out of the power supply. So between ground and 5 volts, we're seeing 5 volts, and ground and minus 15, ground and positive 15, we have 15. So it looks like this power supply is in good shape. That said, I'm not going to use this power supply. And I'm going to unplug this synth before I do anything else. I'm not going to use this power supply because it does have the issue where when these power transistors fail, they fail in a very bad way that sends a lot of voltage everywhere in the synth, and the synth just dies. And before we do anything else, we're going to discharge these capacitors so we don't have an unpleasant surprise. Capacitors can hold a nasty charge even after the power is off, and if you don't discharge them, you will be made aware of that charge in a very exciting manner. All right, so there is a hardwired plus 5-volt connection right on there. So I'm going to have to actually clip that off because we'll have to resolder that later. We'll just have to remember that. And then we have 2 GIS screws here holding that circuit board in. As well, we have screws on the back holding the power supply to the case. And once we remove those 4 screws, this just falls free. There's actually, you can see this is a backing plate. It's actually a big heat sink. And we can remove all of the other 2 screws that will allow us to remove that whole backing plate as well. We do actually have to do a bit more disassembly here. Now, I should note, you'll see some paste here, some thermal transfer paste. I'm going to try and keep my fingers away from it. If you can see that here, it's a dry paste that's applied to this piece of metal here, and I've got it all over my fingers. Fabulous. And it's actually going on there, and it's also on the back of this plate to transfer it onto that. And I need to go wash my hands. I will be right back. So back in the 1980s, Korg and others used a thermal transfer paste containing beryllium. Beryllium is a highly, highly toxic heavy metal that will absorb directly through your skin. Fabulous stuff. So I'm going to use some isopropyl alcohol here to try and dissolve that and wipe it free. You really, really don't want to get that on your skin or anywhere you're going to absorb it, or touch your face or all that kind of stuff. And I should be wearing gloves doing this, but I'm just going to go wash my hands again in a moment. But this is really nasty stuff. And we are going to be reusing this plate and the heatsink. So we do need to clean this before. We're going to put some more environmentally and health-friendly thermal paste on this before we reassemble it. We'll just get rid of this nasty stuff. Alright, so the Kiwisix power supply upgrade board, you can see, comes with the power transistors, but no heat sinks, and also no connectors. So we have to take the heat sinks off the old board here and use the thermal transfer and the standoffs to mount them to this heatsink rail here. We also have to desolder all these old connectors and then mount them on the new board, because apparently these connectors are no longer available, so we just have to reuse what we got. So first we'll take off this rail. Oh, did I mention these fantastic vessel screwdrivers are also magnetic? Aren't they great? You should really go into the description and get yourself a set. Now these transistors have to be connected thermally to the heatsink, but not electrically. They do have to be insulated, and you'll see in a moment when we mount the rail to the, or rather the heatsink to the new power supply, exactly how we accomplish that. So there's the rail that we'll be mounting. These we don't care about. We will be reusing these fuses here, and now we need to desolder these 4, actually 5 and 6 connectors. The plastic on these connectors is pretty soft, so we do have to try to minimize the amount of time that we're heating them up, which is why the desoldering pump is so good. We just put it on there, heat it up, suck it out. The desoldering pump just makes this job so easy. Had this desoldering pump now for all of, I don't know, 6 months, and I've already managed to misplace all the different size tips it's supposed to go with it. So I may have to use just a regular soldering iron to get this off. All right, that's all the connectors out of the old board. All right, so now we'll get out the new replacement board. Get it in here, and we'll start soldering up all the connectors into it. So I will have to admit that this is not my old soldering iron. This is a brand new one that I got, this new soldering station. And I'm nowhere near as quick. I had that old soldering iron for not decades, but close to it. And so I'm really used to using it, and I'm really not used to this one. So I'm nowhere near as fast on this one as I used to be on my old one. My old one died, unfortunately. Okay, so the connectors have been transferred onto the new board. Now we will very gently remove these fuses from the old board. It's 1 amp fuses, and we'll install them in the new board. The new board comes with this little bag of stuff, and what we get, if I can get them out of here, are these thermal transfer pads that allow you to transfer the heat out of the transistor into the rail that goes on there, as well as these spacers that go around the screws, because we don't want the screw because this piece here is metal, and you don't want to short all those together, and so they can't be shorted to the rail. So let's bend these out a little ways so that we have access that we need. And why don't we actually screw the rail in place? That way we know it's not going anywhere. All right, so now you can see we have a gap here behind the transistors. So what we do is we take one of these thermal transfer pads and we slip it in behind like that, and then we slip this on in front, and then a screw goes through that and then through the pad and into the rail. If you notice, the screws have a little ridge, and that ridge, you can see, goes into the transistor to prevent the screw from contacting the tab of the transistor and shorting it out. All right, the last thing we need to do is check the continuity to make sure that none of these tabs are shorted to the rail. So as you can see, all these screws are shorted to the rail. However, they should not have any continuity between any of the screws and the tabs to which they are screwed through, because they're insulated. So that is the check we needed to do, and it passed. So our power supply is done and ready to go, and ready to be installed in new Polysix. So we're pretty close to getting rid of this old case, and if I could find my screwdriver, there it is. I would unscrew the old transformer. And like I said, we won't be using this transformer, but we will be using the screw down hardware for it. Normally, when I'm taking things apart like this, a little trick that I will use is when I take a fastener out and I've removed something, I'll take the thing that I've removed and I'll put the fastener back in where it came from, because then you know exactly where it came from. There's no question. However, because this case is going away, we can't really do that. That said, this back panel here, that's also going to come out and as part of the Kiwisix upgrade, so we might as well just take that out now because that's going to get replaced. So we can pull this cord through. So we can pull this cord through. And there is our power supply input section, which a large portion of this is going to be replaced. So we can just keep this as a separate section for now. Okay, there is a small screw over here that is tying this ground plane into the rest of the synthesizer. So we'll remove that. Okay, I think that is all the things holding the top to the bottom, so now we can get rid of this power supply. This can get lifted away. I wonder if the new case has feet, or do we transplant these old feet? I have a feeling we transplant them. Yes, we do. So let me just put this aside for the moment. And that's it. That's it for this old case. You can see it's just particle board. It's really not well constructed in terms of quality of wood. I mean, it's held together for 40 years, so I guess you can't really complain that much. But that's the end of the line for this particle board Polysix. You can see some of the original veneer on there and on the front there that was used to try to make it look like nice wood over top of particle board. But that's it. That's the end of the line for this case. Well, that's a nasty mess. All the 40 years of dust and God knows what collected inside that Polysix case. And here is the new case. As you can see, it's already got hinges in it. It is walnut end cheeks and front. The base, I believe, is it solid walnut? No, it's plywood, and it's been painted the same. I can feel it's actually a nice fine waxed finish. You can actually feel the nice finish on it. There are some notes on here. As you attach it and close it, make sure it's aligned properly, because it will shear off the lacquer and stain on the end pieces. It does say you need to replace any of the missing screws. Without the screws, for instance, these inserts here, they could fall out inside the thing and cause it to short out and be very, very bad. Oh, and very nice, it tells us here's the screws that are used for the various pieces in case any of yours are missing. So, thank you, whoever it is on Reverb that makes these chassis. You're doing the world a great service. All right, so the old Polysix chassis had the single piece of foil shielding. This one he's used just 5 pieces of aluminum tape that he's stuck down there, which is fine, but it does need to be grounded, so we do need to make sure that all these are physically connected to one another, and if they're not, we'll have to fix that. So just check for continuity. Oh, not good. Okay, so we have continuity there, 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 All right, so it does seem to be rather intermittent. That's not ideal because they do need to be connected to one another because it has to be a solid ground plane in order for it to block emissions. So I think I may just make up a quick little piece that connects all these together at one end. I'll do it down in this end where the power supply is, and there's not so many boards and things to short out. And that way I'll know for sure that these are all connected together. So I will make that up now and come back in a moment. All right, so here's the idea I came up with. The circuit boards kind of come out to here, and they completely cover this up. So I really didn't want anything that was going to stick up and potentially short out on the bottom of them. The first thing I thought I would try is just to solder to this aluminum, which I knew wasn't going to work. But I tested it anyway. I tried scuffing it up. I tried putting some flux on it. There was just nothing I could do that would get anything to adhere to this aluminum tape. So I'm just going to take some screws and some stainless wire and just run it along the edge there and just daisy chain it along. That will tie them all together, and then I will put down some kind of insulation on top of it so that if by some chance the voice board were to actually touch any of those screws, it's not going to short out and cause problems. So that's my solution. We'll give that a try. All right, so let's test it again. Much better. So now we have, and actually if we actually measure between them, we got 0, 0, 0, 0, and 0, 0.3 ohms between the two. So that's much better than it was. So I'm actually going to report this back to the guy that makes these, because that is definitely going to be a problem for people who are using these cases. If you are using one of these cases and you see this, you may need to do something similar to what I just did here, and I will cover this up with an insulator so that it doesn't contact the circuit board. I wish I had some Kapton tape to use for this, but I don't, so I'm going to use a piece of just regular electrical tape, which I know doesn't have the strongest adhesive, but then I'm going to cover that up with a piece of extremely powerful packing tape that has incredible adhesive, and that should deal with that issue. All right, so once the adhesive on this packing tape cures, that is never coming off, and it's well insulated, so it's not going to poke through that and short out the circuit board. All right, so the next step is to put these feet on. So there I've got the old feet in the new case. Very nice. And I suppose we could actually probably install some of these circuit boards in here. And I think what Korg did was just kind of like sit the boards in and then just screw them in wherever they happen to be. And I think that's the method I'm probably going to use as well. It's not quite exactly the same. On my original synth, it was actually, the board was about that far in. So it's about maybe ½ an inch to the right, but I don't think that's going to be enough of a problem that it's going to cause an actual issue with the running of wires. So we'll call that good, and we'll just screw it in place, which is the way I think. I wish I had a GIS bit for my my screw gun here. I don't have one, but it would be nice if I did. I don't want to tighten these too far and potentially break the board, so the last bit of tightening I'm doing by hand with a screwdriver. Okay, so I think that is good. There's our effects board in place. So previously this board went in here like that, and you can see that's exactly where it was connected. So we'll just put the CPU board in there for spacing, and then we'll take our precious voice board and seat that right there next to it. Definitely not like a Roland synth with a steel case where every screw has a pre-tapped hole that is the only place that board can go. This one instead, in true analog fashion, the boards just screw into the wood in whatever position that they seem to look the best. So I'm sure they had a jig or a template when they were originally assembling these, but it doesn't appear to be that critical in terms of positioning. Okay, so we won't be using this. So here's our Kiwisix upgrade board. And it goes right here, just like that. So this looks like it got bent a little bit. It must have got hit while shipping because this is the very first time I've unpackaged it. And these are a little bit bent as well, which isn't a big deal. The connector will still fit. Oh, these are all bent as well. So, okay, well, yeah, there's definitely some pin straightening that has to occur here. Okay, so looking at the old CPU board, it looks like the connectors are more or less the same. They don't have the shrouds on them, of course, with the exception of connector 110. Oh, and that is down here. So that looks like it might be the scanning connector for the board. Everything else looks like it's there. So we'll just line these up at the bottom here. In fact, let's just stick that on there right now, because then everything will be nice and well lined up before I put the other screws in. So we'll put those two screws holding that in. One of the things we do need to do is remove this CPU because the Kiwisix board emulates the function of this CPU. This is the voice assignment CPU, so that has to come out. We'll donate that along with the CPU board to Centaur as well. So the Kiwisix people give us this little jumper here that allows us to plug one end into this socket here. And the other end goes into this connector right here. Just like so. This connector goes on right here, obviously. As does this one go on here. The remainder go out to the front panel. This wire, I believe, plugged into the effects board. Where does it plug in? I don't know. Let's have a look at the videotape. And it plugs into the middle of the three. So we'll just plug that one right back in now. Good thing I took pictures. All right, so now here we have our Kiwisix mod board installed. We've got the voice board and the effects board installed in the new case. We've got the feet on. We could, at this point, take the top and mount it in place. However, before we do that, I'm going to replace the tactile switches in here as well as clean all these pots. So I don't want to do that while it's in the case. So I think what we'll do is we'll call this episode finished. The next episode will be disassembling this top part, desoldering all this stuff and replacing all those parts, as well as maybe we'll get into the Keybed and replace the contacts in there. We do need to install the new power supply and wire it up and get it all back together and tested and calibrated. That's it for episode 2 of Scott's Synth Stuff Polysix Restoration. Tune in for episode 3. We'll be building the power supply using this new fantastic transformer and the new Kiwisix, or the Kiwisix transformer power supply upgrade. We'll be refinishing and replacing all the components in that control surface, cleaning everything, replacing the contacts in the Keybed, and final reassembly, and then we'll see if we turn it on and if we get any sound out of it. Hopefully it's all going to turn on and work just great. I hope you like what you saw here. Please click like and subscribe if you do. It really helps us out when you do that, and you get notified every time we post one of these great videos. If you have any comments, questions, suggestions, especially suggestions, please leave them in the comment section below. I definitely read all those comments, and I really appreciate all the stuff you guys have been posting. It's really great to see the amount of interaction we have. And I really appreciate that you guys appreciate what it is I'm trying to do here. Okay, that's it for this episode. Thanks for watching.